So here we got Helen Altschuler, and she can just mute because I'm gonna go for days. So first of all, Helen introduced me yesterday. It's a pleasure to introduce her today. Helen is formerly of Google. She is now of EngFlow, and she was my introduction to the remote execution API and the option. And I'll credit my former colleague Michael Knight, who basically like hit me on the side and said, "Hey, we should go write the open source remote implementation for RE API," which turned out to be Build Farm. Helen has been a good friend and a great colleague, so she's hosting a panel today on a more integrated build in CI, which specifically addresses the fact that we've all been stuck at home for the last 14 to 18 to 24 months. I don't go out, I don't really know. But where she's going to hear from engineers from Netflix, Brave, and Airbnb. So take it away, Helen. Thank you very much.
All right. Thanks, George, for that warm intro, and great to be here again. So I'd like to introduce the panel. Before I do that, I also wanted just to share some general thoughts and why I think this is a very relevant and important topic to be discussing. So I've led engineering in the enterprise tech space for over a decade and spent the recent 6 years building specifically around builds and developer productivity space. And as such, observed many interesting trends over the years. Today's massive code bases, often referred to as big code, make it difficult for developers to stay competitive and work effectively. Because of the significant increase in volume of 100 times or more in recent decade in terms of the source code volume itself, as well as variety and complexity, companies are looking for ways to scale and be more productive. And what's interesting is that big code is not only a challenge for big companies, small companies that pull in hundreds of open source projects or end up recompiling large open source systems from source, for example, Chromium or Android platform, find themselves facing these big code challenges as well. And so last year, as George mentioned, expanded remote work really pulled all of these challenges to the forefront. Higher network latency, low spec development machines, remote debugging, more challenges around working together collaboratively, all combined with the fact that code bases are growing as well, resulted in accelerated developer productivity efforts, such as creating more integrated build and CI and moving more builds and tests to the cloud. So I'm thrilled to welcome the panel here. Engineers from Netflix, Brave, and Airbnb, and we can have a conversation about how they're addressing these challenges. I'd like to make it interactive, so if I could ask for any audience questions starting now, feel free to collect them and post them. I've got a few questions I can ask myself, but I also would like to give you a chance to interact and understand better the challenges faced by these companies. All right, so let's start with quick introductions. Roberto.
Yeah, hi, everyone. Well, I guess good afternoon, good evening, good day, whatever you are. So my name is Roberto Perez. I'm a senior software engineer at Netflix. And officially, I'm part of the Java platform team. And basically what I do there is be responsible for providing the core language and framework components that enable the Java community at Netflix. My main area of focus right now is the JVM build side of things. So providing Netflix engineers with reliable and well-maintained tooling in order to manage their builds and release software every single day. So before jumping into all these questions, I would like to share a little bit of, metrics or the landscape of Netflix today. I don't know if you had a chance to catch on Rahul's talk probably a couple of hours ago. He gave a great presentation around the CI infrastructure itself, like having 600,000 of builds, 45,000 repositories, and so on. But I want to focus a little bit more into the Java experience at Netflix, which is probably the biggest one at this point, because Netflix grew as a Java shop and now diversifying into other platforms. So from the Java perspective, we have around 190,000 builds per week for almost 1,000 of engineers. And we have 3.2 or 3.3 thousand active repositories where people work every single day. And there is a good mix of languages between Java, Kotlin, Ruby, Scala, Clojure. So this translates at some point into generating 9,000 artifacts that get published to Artifactory. This could be applications, clients, libraries, in all sort of statuses. You can think of snapshots or final releases that needs to be used. So we use Gradle. We use the Gradle Enterprise Suite heavily in our site.
All right, thanks for that intro. Next up, Janusz, if you can introduce yourself and also talk about the kind of scale that you're working with.
Sure. I'm Janusz. I work. I'm a staff software engineer at Airbnb. I'm Polish. So I work on the developer platform, and we enable over 1,000 Airbnb engineers to be efficient and productive. So unlike Netflix, vast majority of development happens in several monorepos or organized by areas. So think like front end, back end, data, mobile, and so on. I understand this is like an oxymoron, several monorepos, but like we are not there yet where we have one true monorepo. And on the scale, we actually do over one build invocation every second, which is just really a lot. So yeah, I think that can be like a relative intro. And we also use Gradle for our backend is all JVM based, Java, Kotlin, a bit of Scala. And we're now looking into Bazel more and more.
All right, thank you. And Mihai.
Hey everyone, my name is Mihai Plesha. I'm the DevOps manager here at the Brave. You might recognize our logo there, or our CEO who created JavaScript and co-founded Mozilla quite a while ago. I lead a team of 3 very talented engineers across the globe, and we don't only deal with spinning up infrastructure and cloud services, but also with building release engineering, which we really like. We have around 600 repos. Our company is under 150 employees, so pretty light. And more than a third of those are engineers or developers. We have 30 million monthly active users and adding a few million every month. So growing quite fast. We have a big variety of languages. Mostly we're built on top of Chromium, but we take lots of things out and add lots of things in. And we're also big lovers of Rust. We have hybrid cloud environments. We do hundreds of builds per week. And every build runs thousands of tests. And I'm looking forward to share the stage and tell a bit more about the challenges.
All right, and I think this is really interesting that there's definitely a common aspect across all of your companies. You're serving millions of users, and those user bases are growing. And so the developer infrastructure, while the size of the company might be different, but the scale that you're operating at and serving is pretty significant. And so I'm curious, in this new remote work, how did that affect your priorities, your developer workflows, and which of them are temporary versus permanent in terms of the tooling, the efforts that you're prioritizing because of that? Let's start with Roberta.
Great. Yeah, I think one of the obvious things that happen is when folks start working from home, either they have less compute resources, like you probably will have this big, massive machine at the office and probably you will start working with a laptop that has less compute resources, or just the fact that you might have a different network speeds because you get better internet connection from the office under the VPN versus at home. So this was something that really impacted people, and they were starting, suffering from, my bill is more slower now because I'm downloading all these jars in particular, or just because I need to upload or download all these Docker images for some reason. So one of the things that we started exploring right away were things like how to do test distribution, how to start executing the test remotely so people don't even need to start using the compute resources locally, and also try to leverage more things like bill caching. Make sure that, for example, on CI, we will go and calculate all these caches stored in a bill cache server, and then users will only consume that and load it locally instead of running these things over and over again. In addition, like on remote work side, now we have a good mix of engineers like either work remotely on a permanent basis or And so we are adapting to it as a company. So Netflix in the past was more of a company that you will be in the office every single day mostly, and probably work from home every once in a while. But now it's getting more like, I would say global within the US. So you will find folks working from the East Coast, for example. So now things like pairing or collaborating became a challenge. So tooling around this was not like very popular at Netflix. What can I do in order to, connecting a call with a colleague and start writing some code? How can I do some proper pairing? So as of today, there is no like an official opinion. So you will find teams doing things like, probably using IntelliJ code with me, or they might start doing something like Topol on OS X, or even finding their own ways to do things. And some people might be like, would like to do remote IDEs, so we are not there yet. So even folks are like creating these EC2 instances where they go and put all their work and work from there. But we're not there yet. So those are the things that we are constantly exploring, and we know that it's going to stay here forever. Because the reality is that not everyone go back to the office.
Yeah, and I think it's interesting. You touched upon really interesting aspects from remote caching, as well as the remote debugging and collaborative tooling. Mihai, what have you seen from your experience in that space, and any other additional challenges you're addressing?
Sure. So Brave has been from day one highly distributed. Actually, we're giving up more of our physical presence away. In Cayman Islands, where I'm based, we're actually growing an office, and we still have a few colleagues here. I think the accent has shifted away to integration or testing integration, especially when you're not at the office and you're not able to look over the shoulder of a colleague and say, hey, we're working on the same feature. Let's do a build together and see if things work there. So that has shifted. We didn't necessarily have the use case of having a data center or having to be in the office to access certain resources. So we were pretty much in the cloud. One of the risks when you're building something that large as Chromium with so many third-party dependencies is either rate limiting your network availability to all kinds of dependencies. So mirroring those packages that you depend on, and also caching compile objects are big things that are going to change the developer workflow. And also, if that is not available, you would definitely need powerful portable hardware for your developers. Maybe you had strong workstations at the office, now you cannot go in, and you're stuck with your old MacBook, and you need to find a solution for this to keep pushing code.
All right, and Roberta mentioned the developers now are in different geographic areas. In your case, you have developers in also very different places. How you handle that aspect?
Yeah, depending on what remote execution or caching system you're using, and we've been through a few, CDNs might help, and all kinds of other things. We do use a lot cloud instances, even for Windows, and we might start looking at macOS ones as well, since AWS supports that. But really not depending very much on hardware and licenses is really empowering to do your best work and to work from anywhere.
Yeah, so more cloud machines, less developer workstations, especially where you can't really easily ship them. Janusz, how do you address the remote work challenges and scalability programs?
Yeah, so I can relate to a lot of things the guys mentioned before. We definitely had big VPN problems. We had all the remote caching and infrastructure before, but we were just not expecting so much load. So it took us a while to adjust to that. Similarly, yeah, I think pair programming became somewhat more important with code with me and stuff. I think it's in general really important for people not to be like siloed and work by themselves during the pandemic. I think just pairing up people was really good to like just get through this together. We're always like very social at Airbnb, like the culture is really good. So there's a lot of friendships and stuff. So that was missed. Yeah, and also, you know, Airbnb also tried to do like some programs like stipend for a better internet, but you can only do so good as your area allows, right? Like sometimes you're just stuck with Comcast, and Comcast likes to go down, and you know, I mean, and things happen. So one other interesting thing is that like because we're more distributed, our peak also changed. Like, you know, our CI peak, and so everything moved. Everything is more like smoothed out now. Like it's just wider. Before it was like closer to the 9 to 5, and then the let's say the China hours, and now it's like more all over the place. So that's kind of interesting. But yeah.
That's certainly interesting. I guess now you're using your hardware resources more efficiently to some extent. All right, so I'd like to call in again that please feel free to post more questions, and I will start asking some of the questions that come up, as well as continue the conversation based on where it takes us from these notes. So one question we have so far is that did the companies here on this panel move through a phase where they used remote desktop environments such as VS Code before moving to remote builds? And do they run remote builds from their end user laptops, or is the client also in the cloud? I imagine the answers will be very different here. Feel free to jump in, anyone.
Personally, I try to avoid doing builds. Actually, I don't remember doing a full Chromium build on any of my 4 laptops. So I can get away with using our own cluster for macOS or the cloud. But I know my colleagues have either powerful machines or workstations. And also, I have to echo what Janusz said, that VPNs are challenging. You have to figure lots of things when you're connecting to the network. We're looking into zero trust and other kinds of solutions.
All right, any other thoughts?
Yeah, so we had remote builds. So the way it would work, you would have a remote EC2 machine where you can execute, let's say, your Gradle build and then download the artifacts. So I also think maybe that is like the first step instead of doing the fully remote with the editor.
Yeah, same for us. Today, the clients, so basically the build tool, still rely on whoever executes them in their machines. There have been some investment on the Gradle side for using, test distribution and build caching coming from CI agents. And some other part of the company, we have a tool called Newt. Newt is basically a tool that was created to try to fulfill the developer local experience when it comes to other platforms. So it is Docker-based. So basically, as a user, you can just go and execute some specific Newt commands and then build out of that of projects like Python, Node, etc. So people in that team started exploring remote execution before even pandemic, but that didn't apply for Java because all the requirements coming from like how to interact with a Gradle build, for example. But we haven't go to a place where you will go and run everything, including the IDE on the cloud. And I don't think we will be there in the next few months. It will take a lot of time, to be honest.
It's certainly getting to that point that developers more and more looking for a more distributed solution. I've got another question coming in. So in moving more builds and tests to the cloud, has this resulted in consolidation, more efficient use of overall compute resources required? Each of you are in different places in that journey, so also feel free to comment on whether you're only experimenting or whether you've been doing this for a while as well.
So I think remote caching definitely helps because you do the computation once and then you reuse it everywhere. I think from the perspective of better utilization, yes, running remotely helps, but you still have to have your laptop. You still have to pay for that laptop. But yes, remote execution helps with utilization because you have this like shared compute farm instead of like a vertically scaling a beefy box to run all your builds.
I think remote testing for us is still like on early stages, but so far it has helped with consistency. The fact that you will get mostly the same if you were running locally versus on CI, which was a problem before, like, hey, why is my build not working locally and it's working locally and not working on Jenkins or vice versa? So having that experience consolidated on remote agents that have the same capabilities and come with the same execution runtime will be a huge win for us going forward.
I think for us it was a bit different since not long ago, as in years ago, processes were mostly manual. Builds to the users were going out from developers' machines. So first of all, we had to automate things. And we were really careful to build PRs in the same way we ship to our users, so using code in the pipelines, and making sure we can identify flaky tests across different builds. And ensuring repeatability and no more, hey, it works on my machine or in my pipeline, but not for the others. I think this is the first stage of it.
All right. We have another question here, and yeah, please feel free to post more questions so that I can interleave them as we have this conversation. For anyone that's watching us, feel free to add questions in the questions tab. In the meantime, we've got one here. So with the move to remote working, what challenges have you experienced in designing operating auto-scaling systems in response to the user load? That's probably touching a little bit more on Janusz's observation as well, but more broadly, auto-scaling. Any thoughts on that?
I mean, for us, we start instances in the cloud, do builds, then stop them. And then when we restart those, we reuse the workspace to cache in that way. So we were pretty elastic, at least in the past 2 years. We have users of Jenkins, but a few other CI systems. So that hasn't been a problem for us, even though there's other drives, for example, optimizing cost. You can do compute safe plans, you can use different cloud providers or use spot instances if you can predict kind of a block of time that your builds can take. You can also put builds in Docker and distribute them on ECS. We try quite a few things in that space.
Yeah, and I guess what's interesting, in your case, you've already been in this remote environment. So do you have these kind of bursts of loads, or is it pretty much spread out throughout the day?
There definitely are. I think most of our colleagues are based in the North American time zones. Also, we do releases on demand automatically. Every day we go out with 3 channels. Some of the days, there's weeks in which we do 3 big releases. So harder to predict, but we're fully adapted to this kind of elasticity.
All right.
Yeah, I think for us, like the scalability has not been like the main challenge when it comes to CI. As Rahul mentioned in the previous talk, we oscillate between 650 to 1,500 agents per day, like coming down and up. But it's more about availability. With people getting distributed, like let's say you go to France or you go to Australia, whatever, when you're working, you're expecting that Jenkins, for example, in this case, or Rocket CI is available for you. And these tools usually require like some downtime just to do upgrades, things like that. So making sure that you are available 24/7 basically now for someone building code at Netflix has been probably the main challenge at this point. And it's not only about CI. So for example, in the Spinnaker continuous delivery tool that we have at Netflix, there are also like pipelines that require Jenkins for some steps in order to release software. So now that we have people all over the world at some point releasing software, it's really important that this infrastructure is available anytime for them. Yeah, availability has been probably the bigger challenge so far.
Right.
Yeah, I mean, we always had auto-scaling. We did some improvements, basically how quickly we can provision a new box from the time when the spike happens, when we can have a new worker. I think in general, like external fragmentation kind of utilization is very good. With utilization on CI, we struggle more with like the internal fragmentation. But yeah, also the comment about availability. I think that's extremely important now.
Has the availability expectations changed now? Especially now that you don't have a very typical day.
We always strive for as many 9s as possible. I think we came to a point where our CI doesn't fail because of us, but of the external systems. We often hear about AWS incidents before they publish it, and stuff like that. So our struggle is mostly on external now. But
you're pushing the cloud providers to the max.
Hopefully.
Yeah, interesting. And like related question around, while we're talking about tools that just came in, what productivity service do you use for CI and why? I think I've heard Jenkins come up twice, but let's talk a little bit more about your CI environment, plus any customizations that you've made.
Personally, I've been using Jenkins or Hudson as it was 10 years ago for quite a while. It's good and bad, right? You can do so many things with it. It's super flexible. And there's a big advantage in having not having fragmentation and having all things in one place. Not that much, let's say, from a security point of view. But we also use GitHub Actions, code build, TradeVCI, and a few other things. Those have different advantages or use cases, but we're pretty happy with Jenkins, but there is a lot of tinkering and hacking around. It still is the load is predictable for us. There's not that many upgrades, just take a few minutes for us. So there's no challenging part for us to write in that.
That's actually, before we get other thoughts, I'm curious as well, because this has come up in many other conversations with other companies, is that which of these CI systems work better with build tools or give you a better integrated experience? We've talked to companies using Jenkins, looking to migrate to BuildKite or migrate to GitHub Actions. And since you've experimented with both, be interesting to hear that.
Yeah, there's also the question of price. Of course, in GitHub Actions, you can use your old build runners and things like those. There's also the other question, do you want to depend on GitHub to have their platform up, which sometimes has been unreliable for us? Or are you happy and you have the capacity in your team to manage Jenkins and run it yourself? It is more work, but at least for us, so far, it seems to be the good solution. Definitely needs some improvement on the UX side. Even with Blue Ocean, things are not in the most expected places if you want to dig deeper into failure causes or other things. So definitely the UX can be improved. I'm curious to hear how Airbnb and Netflix have a better experience for the developers in that aspect.
Yeah, so we are heavy on Jenkins today. So we have something called Rocket CI, and Rocket CI is basically our flagship product for engineers. And it's not only about Jenkins experience, it also has connections to our systems like Spinnaker, like we use Bitbucket, so we don't use Git. And that probably will explain why we haven't tried GitHub Actions at this point. So Rocket CI, it's not only about the Jenkins server itself, or more of an integrated experience when it comes to continuous integration. And it provides us ways to basically extend functionality in a way that we can provide an abstraction on top of it. So we can create richer experience for users, like creating our own portals or integrating with the Spinnaker to show information, have events that we can react on the build side, things like that. Obviously, there have been discussions, hey, what about GitHub Actions and other CI tools? But the reality is that the effort moving to those things, especially with this multi-repo setup, will be not ideal, migrating all those jobs. And also the fact that we need to move away from, for example, Bitbucket into GitHub, that will be just another challenge for the people managing that service. And we really like Bitbucket in some ways, similar for extensibility. Like we have a Rocket plugin that lives into Bitbucket, and it provides us a way to connect all these things together. But probably GitHub Enterprise wouldn't allow you to do that. It's not that extensible. You need to do webhooks, things like that. So it's a different kind of problem, I would say. Yeah, I think that's probably why we like Jenkins. And also it's very flexible. It could be the good or bad, right? Because people can basically go and make themselves admins and install whatever plugin they can think of. But at the end, it allows you to do the job. But we try to keep Jenkins as lean as possible and use the tool that I mentioned before, Mute, in order to containerize what you need for your build. So if you need to run npm build that needs to install specific dependencies, it should run in a Docker container instead of really installing all those things on the Jenkins agent. So we are moving more into containerized builds going forward, I would say.
There's a question, audience question about Jenkins, which I can certainly relate to. So Jenkins feels like it reached its maximum potential years ago, and has been holding us back since then. Which, if any, open source projects would you like to see take over from Jenkins across the industry? And also, do you agree with that statement? Maybe this works just fine for you, Roberta. Maybe starting from you, do you think there are challenges with it that I mentioned, and other open source projects that you think are good contenders?
Yeah, I mean, there are definitely good contenders out there, I would say. To be honest, I'm not like an expert on that topic to go and come with with an opinion on it. But from the Java platform perspective, we see Jenkins really as a good fit, but we try to abstract away things from there, from users. So basically, we try with Rocket CI, so people can declare what they need on their build within their SEM repo, so they don't even need to deal with configurations at Jenkins level, for example. So at some point, the configuration becomes something declared within your own repository. And we would like to get into the point where you don't even know what Jenkins is, maybe. Like, you are really talking to Rocket CI, and whatever happens under the hood, you shouldn't know. You should just get the inputs and outputs, and that's pretty much it. Yeah.
So your answer is more like use what's good and obfuscate the rest, and more of your internal replace with your internal tooling.
Yep.
Yeah, interesting. And Mihai, what are your thoughts? And also, do you agree with the statement that of Jenkins holding people back and other alternatives?
Yeah, as I mentioned, I think the UX definitely needs some improvement, and that's crucial to adoption and to having a pleasant experience with any tool you interact. We're a small team here, but I think at this point, we're in a good place to start evaluating other things. Actually, there is someone in my team who suggested TeamCity. It's not necessarily open source, but definitely a better UI. And I haven't been keeping up to date with what other CI systems are. There might be something much better for Chromium or that kind of builds, or something, let's say, more synchronous, that does things in a more proactive way rather than polling SCM or so, or test integration earlier. But that will be a very interesting conversation for us in the next months.
Exactly. All right, there's a question. Both Roberto and Janusz mentioned Gradle and the potential migration to Bazel. Can you elaborate about specifically what are your challenges with Gradle at that scale?
Sure. So I would imagine Roberto's answer might be a bit different because we are using Gradle in a monorepo. I think Gradle was never designed per se to do this. So there's multiple issues we have. One is the configuration time. It actually takes a really long time to, it's kind of like a loading phase in Gradle equivalent. And it just takes really, really long for our entire monorepo. And there's, to my limited understanding, I think it's all like single threaded, and basically there's like some now configuration cache, but it's not really cutting it for us. And another big problem that we have is for the large builds, how do you actually run them on CI? Today, we basically statically shard the build graph and map it on CI nodes. I think it's up to like 50 nodes. This is like really inefficient, one on the utilization part, and it's just really, really complex. We would much prefer the model of remote execution where you have a single driver that does everything at the task level, at an action level. So I would say these are like two major issues we saw with Gradle. Also, hermeticity is really hard, and for monorepos, it's actually sometimes very hard to figure out what changed, and sometimes it forces you to like rerun your entire CI, which is extremely expensive and time-consuming in a monorepo.
Yeah, I was actually curious whether during this conversation we'll get onto the monorepos multi-repo debate, but yeah, some of these things are probably not as big challenges because you're not on monorepo. And
yeah,
what do you see?
Yeah, so I don't see ourselves moving to Bazel at all. It doesn't fit either the culture, because the Netflix culture is more like a context, not control, and freedom of responsibility, which means that teams are not gated in terms of when to release things. And it seems like monorepo at some point becomes gated either by a build team or just by some sort of infrastructure. And on the other side, today we have 40,000 repositories across multiple languages. So try to consolidating those will take just a while. And then basically change the tooling will be another challenge, right? So probably, I would say, 10 years ago, maybe 15 years ago, Netflix was a big monolith in Java. And there was this decision to start looking into what now we call microservices, which I don't know what are they anymore anyway. So we started looking into that. And we decided to basically every single thing will be its own service, its own repo, and it will have its own fat client. And we got ourselves into the problem of dependency management hell because of we need to integrate binaries every single day. So we have spent the last 7 years basically either working closely with Gradle or doing internal tooling to make dependency management less painful land, I will say. And we're getting there. We are getting much better. We wrote a lot of tooling for keeping people up to date with latest versions of particular libraries, linting their builds, and so on. So it's a lot of infrastructure we will have to modify and also change how people work within Netflix in order to achieve something like moving to a monorepo or moving to Bazel. And of course, there are more challenges, right? Like now we are investing on things like, how do I do distributed refactoring? How can I, as a library owner, go and say, you know what, my public API for this particular library is going to change. How do I know who's using my things? And how do I go and modify without breaking them? So with a monorepo, probably you wouldn't have that problem right away because you can go and integrate the code and see what breaks. But with this world of multi-repo, it's, at least in the past, it was really, really painful. Today, there are more tooling out there. Like you will see things like Atomis, you will see things like SourceGraph, even like something we call Modern, that basically allows you to understand all the repositories, understand how the code is getting written and used, and then write campaigns in order to refactor that code. So it's good to see companies exploring this space, and those are things that we are eager to adopt and start using within Netflix.
Yeah, I think that's really interesting. While this is a build and CI kind of integration, it begs the question at the scale of multi-repo, how do you effectively understand and analyze code across all of these? So make certain tools more necessary in that specific environment than maybe otherwise it would. The next question is, I think maybe it's a follow-on question, likely for Janusz. Do you allow all developers to access all code? Google states that most, not all, of the code in their monorepo. Is access restriction on code artifacts old school?
So people can see all the code. Not everyone can commit to every code base without appropriate approval from a selected list of reviewers. There are some special repos at Airbnb for financial purposes that have to actually live outside of the monorepo, and those have more restricted access, but everything within the monorepos is readable by all engineers.
Okay. Any other thoughts from anyone else on this, on the code access and how relevant that is in the future?
We have something similar. We have multiple repos and everyone has access to them, except for a few repo types like financial, billing, things like that, because, you know, compliance. But other than that, engineers are basically open to see everything. Even like it's overwhelming at some point because you have access to all the code and all the documents within the company. So it could be overwhelming to try to, you know, explore everything that is out there.
Yeah.
Yeah, it's also important to mention that our security model assumes that the code can be leaked. So
interesting model. So mitigation and I guess rather than prevention. Interesting. Next question is talking about the different OS distribution platforms that you might have support in your builds and CI. So how many of these different distribution platforms and OS and do you support? And if you could drop the support for one of your supported platforms, what would it be? Let's start with Mihai, since you're obviously building across multiple platforms.
Great question. So our PR builders and also what we show to our users is on 5 platforms. So we have Android, iOS, macOS, Linux, and Windows. If I were to drop something, I would drop 32-bit support for Windows. And also for Android, we build 6 architectures, which go to the Google Play Store. That's kind of a requirement, or to cover older devices or different variants. For Mac also, we had to introduce ARM64 builds with the new Apple CPUs, the M1s. That proved to be funny, especially during New Year's Eve. And yeah, Windows, definitely Windows 32-bit is what I would drop. And also we're going to have our iOS app ideally built from the same repo. It's the last one standing out, built separately from Chromium.
What does it look like at Netflix?
So the CI team basically owns the experience around Jenkins agents when it comes to Linux machines. When you need to test things against like OS X or some sort of operating system, you are basically on your own, but not really on your own, because they provide tooling in order for you to spin up Jenkins agents with what you need, so bake them and run them with proper security and things like that. It's I will say it's a good spot to be, because you don't need to understand all those platforms in order to provide or fulfill needs from these users. You can provide like basically the building blocks so they can start their own agents and run the code that they need to run. So it allows the CI team to scale going forward. So something that I would like to mention is that this CI team, Rahul's team, is probably composed by now. It's formed by 4 people, and they serve like 2,000 or so engineers. So they need to do these decisions in order to fulfill needs for everyone in the company.
Right, so you got to prioritize that. Yeah. And Janusz, how many platforms are you building?
Yeah, so I mean, so maybe we're the least interesting of the bunch here. We built, iOS, Android apps, and web. I think maybe one interesting thing is that we are looking at ARM from the cost perspective of just like running backend and stuff on it, if it's better per dollar amount. If I could drop one, I think I have a pet peeve with Apple. I think they make things much harder than they should for running CI. They're always kind of like a special cookie. You have to actually execute on Apple hardware. You cannot virtualize it. This makes the entire CI unification much harder to like run the same exact things on Darwin on macOS. So I mean, obviously we cannot drop because it's very important. But if I could have one wish, I would ask them to allow. For instance, Android is much simpler.
Yeah.
I wanted to.
Go ahead.
Sorry, go ahead.
Yeah, if you have anything more to add here, otherwise I was going to go to the next question.
Yeah, I mean, I'm looking for us to add, for example, ARM64 support on Linux and also on Windows. Windows, Microsoft is probably going to do some interesting things in that space. Personally, I did a build a few months ago for Raspberry Pi or Google TV. But I was curious if anyone does any kind of cross-compiling, as in building Windows binaries on Linux, or getting away from Mac by building on Linux.
So we looked at cross-compiling for Mac. The problem is you cannot move everything. So it's kind of like a hard effort to support. So we're not doing it.
Is it just the signing that you didn't find portable, or more?
No, I think there's other problems. I'm not like an iOS expert, but like I know there's like Xcode where it has to run, and it's just complicated. We do, because we use a lot of JVM. We can, I mean, kind of cross compile, right? Like we can run it on Linux boxes and then use on Mac laptops. Engineers can use the artifacts, but that's kind of simple.
Yeah, related question to that actually is, what's your take on supporting different hardware platforms? And do you rely on cross-compilation in all cases? Roberta, I'm not sure if that's particularly relevant in your case.
No, not really.
Yeah.
We're not doing any cross-compilation now, but definitely, for example, the challenge with Windows builds is they seem to be slower. I mean, they really are slower. Either disk performance or when fetching dependencies and working with the disk in the network, it would be really nice to get away from that. Also, AWS instances for Windows are twice the price of the ones for Linux. Another thing to consider.
Yeah, the hardware market is going to be interesting to watch as more cloud providers perhaps compete with each other on that front. What's the weirdest programming language you have to build, and what's the most difficult to build? And maybe the two don't have to be the same, but it's an interesting question for sure. Who wants to go first?
I believe we would like a way to build Rust faster, now that we sped up our Chromium or C++ builds. But we have lots of things. We have Go, we have all kinds of Kotlin, Android, Java. Any
weird languages at Airbnb?
I wouldn't say necessarily weird. Airbnb was a Ruby shop, and I would say it's really, really hard to make it work on your laptop. but yeah, I don't think we have like particularly weird languages.
Yeah, I don't know what is a real language at this point.
What's define a weird language?
Yeah, so we have a mix of everything, right? We have JVM languages, we have Node, we have some Ruby, we have Python, R, Go, most likely some Rust at this point. And I'm not familiar with programming languages that are probably used for things like the TVs, for example. I know there is C++, so we have a good mix to even say like what is a real language at this point, to be honest. Yeah.
I hope we'll be able to have some Elixir very soon, so that would be a nice answer to your question.
All right. And so in terms of major initiatives that you're undertaking, can you comment on anything specific in the CI space, and especially when it comes to how do you make that more seamless for your developers? I think, Roberta, when we talked earlier, there was definitely some efforts related to making it seamless, making it also invisible, whether you're doing the build or CI. What are some of the major efforts that you're doing towards that?
Yeah, so as I mentioned, Rocket is abstraction on top of Jenkins, and there are multiple efforts around that. One of the things is how to do more configuration within your repository. So from the Java perspective, we are spending more time with the CI folks in order to get experiences like cross-compilation on multiple JDK support, like how to build a library against multiple JDK, or eventually how to build Scala projects, because Scala is fun, right? For binary compatibility. I will say that also we have worked with the CI experience in a way that we work on things we call Rocket enrollments, which allow us to deliver changes every single night, and this is configurable, where you will get every single night pull requests with dependency updates, linting updates for your build files in Gradle, Nebula Gradle upgrades, so make sure that you're on the latest Gradle, for example. Even the CI team is working on ways for you to create your own custom Docker image to run your build. So at some point, Jenkins or the CI experience becomes some sort of a scheduler instead of the worker executing everything. So we'll be just like, you know what, let's leverage this to our Titus. Titus is our like compute orchestration platform, which is built on top of Kubernetes. So we will go and say, you know what, take this Docker image and execute all of this in there and just give me the results back. So it will be more like orchestrating things rather than really executing the build within the Jenkins agent or some other agent in the future.
All right. And yeah, in terms of better CI and build experience, Janusz, you mentioned some other thoughts around what your goals are. There's a related question to that around what are some of the key attributes that you would want from your build system, Bazel or not, so that it integrates well with your CI setup?
Yeah, I would even say like, you know, I think one big problem is that there's this like configurations split. You have to maintain two complex systems like CI and build, and they're both underlyingly trying to do the same thing. You have some DAG of tasks that you want to execute, and I think it's cognitively hard on the developers. So where we are trying to go with this, whenever we can, is like put more and more things in the build system itself. Like you could imagine a very simple, you know, CI system that just responds to a Git webhook, runs a single line Bazel invocation. That's your CI, right? And publishes results somewhere. And I do think that the build systems are getting more and more powerful. They're much more complex than today's CI systems, and I hope at some point there will be a grand unification. But for now, we are basically trying to put more and more things in the build system itself. Also, the configuration language, you know, like our CI is still like a YAML frontend. I just think build systems are just so more powerful by giving you a real programming language. So I think that's really useful.
Is there anything that you're doing at Brave, Mihai, in terms of more tighter integration?
Well, first of all our pipelines and infrastructure, so it's coded. If it's not in the code, it doesn't exist, or that's our state of, that's our source of truth. I think for us, it's very important to have faster builds as much as we can get that. For that, we're using ngFlow's remote execution, which is based on Goma. which I think is the right way to do it, as we migrated away from SE cache just recently. And the other thing is to have reliable CI. For example, I think I mentioned we build at every commit on 5 platforms. The results of those get in a nice summary in Slack, direct to the author of the PR. That can include a few other colleagues if need be. And I think our challenge is to make CI less destructive. So for example, if one test fails across all the builds or something was merged and it breaks something in master or in the main branch, you want to exclude that from the other builds and to not hide other failures. And also to, we also split the CI pipelines per platform, so it's not all in one. So kind of making failures more atomic or easy to distinguish there, and also to notify separately, trying not to hide when things fail. So as visible as it can be, we're going to try that.
Yeah. There's a interesting question around builds. So do you decouple your builds from the system by having hermetic toolchains, or do you rely on precisely configured host systems, so containers, to ensure reproducibility? I'm curious, maybe to start with Roberto, since you're not using Bazel, which claims to be strong in this particular aspect. How are you handling that?
Good question. So right now we are exploring so one of the things with Gradle when it comes to building JVM projects, well, any kind of projects, that you need a JVM or a JDK to be installed for you whenever you are running that. It could become a pain when it comes to enforcing or selecting a particular JDK that you want for compiling your code. For example, in Netflix, we use Azul JDK, and it's quite simple for an engineer to go and install a JDK on their machine that it's not the same, either Oracle or Adobe OpenJDK or something else. So we want to be consistent for what you get locally, what you get on Jenkins. And today, it's basically what you install. So we are moving into more of either in the container to provide proper JDK, but that probably wouldn't work because engineers are not a big fans of using Docker containers when it comes to JDK development. At least at Netflix, they really love the interaction on IntelliJ and being able to do everything that you could do there. And having Docker integration will require a lot of IDE work. So we are spending time on what Gradle calls the toolchain support, the toolchain API. So at least we can be consistent when it comes to what JDK you want to select to run your things. And it will be great at some point Gradle allow you to even not require a JDK to run itself. So everything is just self-contained, and you can provide the JDK, for example. But still, when it comes to interacting with other tools in the operating system, that's not totally part of the build tool itself or the build configuration that we provide. We still rely on, existence on the environment, but that's up to the engineers at this point.
And we've got a question around provisioning, a more technical question here. How do you provision manage cloud VMs for CI purposes?
This connects to the previous question. And for us, we have AMIs, so we kind of bake cloud images where we kind of freeze dependencies necessary for the builds. But on the code side, we also pin dependencies there to aim to get reproducible builds at some point. Now with the transition to macOS cloud agents, I'm happy that there's an option to also have AMIs for those, even though they're like bare metal physical hardware. And that could take care of all of our needs. That would be the last thing that was harder to automate. We had to use Ansible, or whenever we had a new macOS build node, we had to configure it and then add it to the pool. But that is going away.
Anything else to add there from Roberta and Yash around specific challenges in provisioning? All right. Well, we'll get to a related question. We just came in, but it's definitely related to our discussion here. How do you optimize code checkout times in CI?
That's another good question. I believe you can, depends on the repository, but for the Chromium side, some people might know there's over 1 million commits in the Chromium code. So definitely you don't need all the tags, or you can do a shallow clone with a history of one. That's sped up some things for us. Also, we do have an environment variable, for example, in our repos for Git cache path, where you can cache frequently checked out repos, and you can just use the local copy if it's up to date, rather than using network.
All right.
So we use reference repos, and also our CI is not able to call GitHub directly because we would just melt it. So we have our own read-only mirror called commitment. So there's some replication lag because of this, but and I mean, the standard thing probably happens in CI where we only fetch the delta and then mount the repository directly in the container.
In our case, I don't think we suffer from cloning as you might suffer, folks, because of the multi-repo approach. However, there are cases where the Git history is really big, and we have seen like a lot of slowdowns. We just try to keep track of those, and we don't have a solution for that yet. We have been discussing things like either change the way we clone those repos when running on CI or some internal processes. So one thing that we have internally at Netflix is called Niagara. And Niagara is basically a tool that allows us to schedule containers and execute a particular set of tasks on given repositories. So what we do, for example, is we can test all the repositories at Netflix to use a new version of a library or a new version of Gradle. But this can overwhelm Bitbucket in this case. So we have been working more into like how to make Bitbucket more reliable in terms of like either mirroring or creating more scalable clusters, other than really fixing the cloning side of things. Because at the end, the repositories are not big enough. It's more about the availability and how much clones we perform per second or per minute. So yeah, I think it's a different problem to solve.
Yeah, absolutely. All right, well, we've got just a few minutes and two interesting questions. So first of all, when it comes to metrics and how do you measure your success? There are certainly standard metrics that DevOps research and assessments team has come up with, DORA for short, metrics such as deployment frequency, mean time to recover, mean lead time to changes, and also change failure rate. So these are some of the metrics that they've been assessing or helping companies assess each other's or their own productivity efforts. How do you measure your success for various of these efforts that you implement?
So we track quite a few metrics, but we very much care about speed. So we care about P50, 75, 90 of build speeds at different times. Locally, is it clean build? Is it incremental? And then on CI, is it at PR time? Is it during merge time? Is it during mainline? Maybe another interesting thing is we have something called test levels, which is it's like an objective measure of the degree to which all the projects at Airbnb are tested. And they're like specific to the domain. It's like on 1 to 5 scale, but it's fully automated. So for instance, do you have code coverage? Do you have integration tests? Are your endpoints covered? That sort of stuff. And that we try to give some objective measure of like how well the project is doing. And then the leadership can see basically what's the overall test levels for their org and like what are the areas they should invest in. So maybe that's one of the more interesting ones.
All right, Roberto, you got thoughts?
Yeah, so for us, the problem comes with every build becomes like unique because you have multiple repos and each one of them have different sizes. So you will find builds that take a few seconds versus builds that take 15, 20, even 45 minutes. So really having like a measure around all these 3,000 repositories is hard. But we do keep track things like overall time, how much time we are spending on tests. And this is why we decided to do like test distribution, things like that, because we knew that 90-something% of our time was getting spent on just running tests every single time. And similarly in Gradle, we do things like measuring configuration time and then try to do some sort of like consultancy with teams that we know that they are in bad shape and try to get them into a better world. But it's difficult to come up with a solid number like we want to have like, I don't know, 1 minute builds because it's not ideal for us because of so many repositories. So we just try to keep like a good baseline and try to understand what happens when we introduce new versions of libraries or new versions of the Gradle tooling. So we understand if there is like a performance regression. And then when teams comes to us saying like, my build is very slow, then we work with them to get into a better world when we say, you know what, we're going to spend some time with you, understanding what's happening, and then help you.
All right. And Mihai, any thoughts on metrics?
Yeah, it might be a bit different for us. I mean, being a startup and given the pace and the growth that we've seen, we don't necessarily have uniform processes. We're super light on meetings. We don't track hours. We don't have like story points or velocity, which in a way it's empowering or liberating, let's say. We do care about build speed. I think that's easy to notice if that increases, especially in certain stages of the build pipelines. And personally, I also care very much about code quality. We use Sonar Cloud for that. And also security. Actually, DevOps team is under our Chief Information Security Officer, so security is a pretty big focus for us. And there's some other metrics we track there.
Interesting. And you touched upon a little bit on the productivity aspect. This is the question I was holding to the end, as it's a nice wrap up for the discussion, and it's a little bit more meta. Have you perceived changes in the overall productivity in your companies due to remote work? Trick question.
Hard to say for Brave since we've been remote from day one. But the better CI means better productivity, I would say.
Better CI means better productivity. That's a good conclusion.
I think it wouldn't be fair to say that productivity is better or worse because every single person went through this pandemic in a different way. Like you might have kids, you might have family to take care, so you wouldn't even be able to put the same hours, let's say, of the same effort and be on the same, I would say, mental or physical state versus someone that my case that I'm with my wife and at some point I felt more productive. And obviously people are different when it comes to working from home versus working from the office. So I think it's hard to come up with a answer to say, what productivity got better when it comes to working through the pandemic.
It feels like overall it's a wash, kind of like what Roberto said. For some people, this really works great. Some people just really love this environment. They can just be in the tank and just code uninterrupted. For some people, it's much harder. So I think overall, it just came up to be similar to what it was before.
Yeah, with all of this, certainly our goal as teams helping companies with developer productivity is all about making sure that we understand different metrics and what different drivers. And if build speeds are important, let's focus on build speeds. If repo, if there are challenges with commits and commit times with repo, let's focus on those. And ultimately, I see our role in a developer tooling space as an opportunity to help companies stay competitive, manage through these different cycles that happen in the development workforce, remote, other challenges that are happening, and continuously invest in tools for engineers and give more productive environment for them to work with. And with that, I will wrap up the panel. Thank you very much for your time. This has been super valuable. There's still a couple of technical questions that I would suggest if you can take a look at it, feel free to post answers to them in the chat. Or at this point, we're at the end of the conference, so not much is going to happen in the water coolers. But the most important thing is that this conference, this meetup, is about bringing thought leaders, experts, and enthusiasts in the build community across a variety of build systems. And so now we're all connected, and we can continue these discussions outside of the meetup as well. And so I welcome more questions and more discussions between each of the panel members as well as each of the audience members.